what we're going to do at this point is we're going to do one more example. We're going to try this out. I'm going to go a little bit faster on this one. I know that first problem was like 12 minutes there, so we're going to go a little faster here. But it's still going to be the same idea. We look at the numerator. We ask ourselves, can we factor it out? We can. All three of these have a 2 in common. So I'm going to take that 2 out, which will leave us with 3n squared plus 8n plus 2. And then we are going to divide it by 2n squared minus 2. Sorry, we're not doing that yet. But in the denominator, we do have some factoring out we can do. We can take out a 2, and then we're left with n squared minus 1. Now, we can still do a little bit more here. In the numerator, we can box method this. We have 3n squared plus 8n plus 2. That's going to be something we want to box method. So I'm going to do that real quick. 3n squared, 2. They will multiply. 6n squared. We want factors of 6n squared that add to equal our middle term, 8n. Do we have those? Factors of 6 that add up to 8. That doesn't seem possible now, does it? Why doesn't that seem possible? Because I messed up. I only took that 2 out of the 3. I got distracted, and I did not write that as a 4 as it should be, and that as a 1 as it should be, because we took out the 2. So my sincerest apologies at almost making us go very astray. We need factors of 3 that add up to 4. Factors of 3 that add up to 4 are going to be 3n and 1n. We'll put those in our boxes. 3n, 1n, and then we'll see what they have in common. So we will take out the 3n that these have in common. That is a positive 1n, so that comes out, and then a 1. These have n in common, and these have 1 in common. So we end up having 3n plus 1 and n plus 1 as our binomial factors of this numerator. So the numerator, after box methoding the polynomial that was left over, gives us 2 times 3n plus 1 times, sorry, I got off the page there, times n plus 1. The denominator can be difference of squared, because n squared is a perfect square, 1 is a perfect square, and they are subtracting. So we get n plus 1, we get n minus 1, and then we still have the 2 on the outside. So 2 times n plus 1 times n minus 1. So what we ultimately see whenever we go to cancel out the things that we have in the numerator and denominator, we have a couple identical entire binomials here. We have an n plus 1 up top and n plus 1 in the denominator. They will go away. We also have a 2 in the numerator and denominator. They can be canceled out because they are not adding or subtracting anything, and they're the same. So those 2's can go away. This will leave us with merely 3n plus 1 and n minus 1 as our fully simplified expression for this original equation. So again, kind of removing all of the fanciness to it, removing all the nonsense, and getting down to just what it has to be. So we're going to stop there in terms of examples. I would recommend trying out number 8 on the worksheet. Give that a shot, see how it goes. If you have any trouble with it, let me know. I'll be more than happy to help. And otherwise, we will pick up here tomorrow. I'll probably go over number 8 so that you can see if you did it right, if you did it wrong, how it went. And then we'll do a couple more things. So thanks for tuning in. I will see you guys tomorrow.